Much. So the show today is really about how do you achieve the DevOps promise, the software development velocity, cycle time compression, but without compromising security and governance. And how do you do that at scale? Before we get into that subject, the big question is, what really got us here? Why are we talking about security in context of developing particular application? And why do we decide to develop the application versus acquire it in the market? With the whole cloud revolution, there is an increasing split between the applications which are acquired, and cost of acquisition of the application is constantly decreasing, and application that you decide to develop on your own. For example, in GitLab, here in GitLab, we use approximately 80 different applications for business, generally available for all employees. 79 of them are acquired externally. One, GitLab itself, is something that we develop, maintain, and run internally, and that is also our product. Product is a keyword here. Many of the organizations who, in the end, decide to build something internally start to think about this as a product, something which is potentially reusable, not only internally, but also externally, with the varied audience of external customers or clients. And that puts a lot of additional requirements against that application. So when you think about that decision tree, thinking about, do I develop or do I outsource? And by outsourcing, I mean outsourcing not only application itself, but also its operation and security, which is easier and easier to do these days. There is a discussion about cost and holistic cost of the whole product. There's the discussion about the risk, of course, the risk of delay, the risk of breach, the risk of data leak, different operational risks like risk of downtime, the compliance issues, the potential long-term development strategy for that application, and eventually, even the talent management cost. How do I make sure that I have right talent on board in order to grow that application? So the discussion is really much broader than the application itself. The discussion is about operational model, the discussion is about security model, the discussion is about business risk, the discussion is about HR policies behind it. It's really broad subject. And now, because of that complexity of that subject, many organizations now tend to think about this internally developed application as a product. And when it is a product, it needs to be ready for multiple potential users. It is convenient and enabled by technology these days to think about it as a cloud native application. What is cloud native? Cloud native is a way of building applications to make them scalable and make them easy to develop at scale. So not only operationally scalable, but also easy to develop at scale. It's very often coming bundled with microservice approach, when you can have multiple development teams working concurrently on developing the application. It very often comes with the API first approach, where the API can be consumed by other modules of that application, existing or not yet existing, or future modules which might be developed one day. And that's very often coming in a way that it abstracts this application from the infrastructure. The application can containerized, it can be deployed using Kubernetes on arbitrary infrastructure. So it's future-proofing the operating model of this application from the underlying infrastructure. It's all beautiful, it's all great, it's all kind of using the technology that we have available today to make that application as much productized and as much universal as possible. But the more microservices you have, the more APIs you have, the more interfaces you have to test, the more complex DevOps process around it becomes. McKinsey calls that DevOps tax. The cost of integrating multiple tools in the deployment pipeline, the cost of maintaining automation, the cost of upgrading all that infrastructure, the cost of surfacing the changes in the scripts and making them visible to the whole team. That's all part of DevOps stacks. And if you have monolithic product like we used to have 10 years ago, then this DevOps stack is given. It's one. When you have multiple services, like 20 different services, this DevOps stack obviously multiplies because you need to maintain that automation for each of those services separately, regardless if this is a team of 50 or if this is a team of 5. They will need similar type of automation to standardize. So clearly this productized approach, this cloud native application, they call for different approach to think about DevOps and to think about security and to think about risk in the longer term. And when you look at the landscape, there is more than just application. Again, here is the quote from Checkpoint Research, where they found out that most security teams, they focus on the application, but there is a big space which stays neglected, which is how do you maintain the infrastructure configuration? And if you think about the application as a product, this comes as a whole. I mean, securing application does not move you that much forward if you do not think and test everything as a product from the very beginning, which is application code, which is dependencies, which is the infrastructure and its configuration tested in one go. So traditional approach to security, coming from the years where we really have had much smaller change cycle, is more like a bolt-on. Somebody developed application for me. Is it an internal team? Is it a third-party provider? Doesn't matter. We need to secure it. How do we do that? Well, we bolt on some sort of web application firewall, IPS, any other security infrastructure on top of that application, and we start filtering traffic to and from it. And this approach assumes that there is a boundary, and it assumes that there is a certain segment which is secure, and outside we have this vast insecure world, and we can filter on the boundary. But with microservice architecture, there is more and more boundaries, and those clusters are smaller and smaller. And this approach becomes inefficient. On the other hand, the speeding up change cycle creates opportunity for security team to inject certain checks early in the application lifecycle. And everybody keeps talking about that, calling that security shift left, calling that DevSecOps. But how do you really do that? To make that efficient, to make that culturally possible, especially that security team is typically 10 times, 20 times smaller than the development team. How do you make sure that the security team knowledge and experience and expertise scales up to that whole speedy process? So you might know this 50 years old rule called Conways Law, that organizations typically design their systems around their structure. So the systems will mimic the structure of the organization. And based on that, there is a concept Roy van Rijn came up with, which is called inverse Conway maneuver. So if you have organization with certain structure and the systems are built along that structure, if you start altering the systems, you have the potential of breaking silos and make people collaborate easier. And you have the potential of, by changing the system, actually breaking the silos and changing the process and making people work with each other easier and collaborate better, which is all we need in order to make that application a proper product, something that that is managed as a whole, also in terms of security, also in terms of quality. What GitLab is doing, which can support that, and I'm telling you this story on GitLab example because our approach to DevSecOps pipeline as a whole is very integrated. GitLab is a single application for entire DevOps. And there is at least 3 potential gains from security perspective. Because what GitLab does is we start with project management, code creation, CI/CD, securing it, releasing, but also managing the test and dev, and also production environments in terms of configuration, in terms of monitoring, in terms of security policies. There are three takeaways. Number 1 is what happens if you make sure that you scan every change very early and surface the information about the impact of that change on security very early in the cycle, when developer is still sitting at the keyboard and remembers what he or she has done. This is psychologically much easier than getting that information 2 weeks later, when security team is actually able to do that scanning manually or using their tool and will submit a report. Number 2 advantage from security point of view of the integrated approach is that you can actually control the configuration of the environment, including security policies as code, and easily replicate them across environments. So you're getting the advantage of testing against certain security policies early, and knowing that a firewall rule breaks something early in the cycle rather than late, and then doing the rework and fixing things before, once they are detected on pre-prod on some other senior environment. Both of them require you to control the infrastructure tightly and be able to provision dynamic environments, provision the test environments for the purpose of particular test, and not waiting with the test for particular environments. That's a very important mind shift in the way of thinking. And then there's a third area, which is, if you have integrated product, you get the single conversation, single permission model, single user database, single data model, where everything is auditable. So whatever happens within that structure, any change which happens within that structure, is very easy to surface and audit against. So focusing on the first one, on the comfort of the developer working with the change. In traditional setup, security tests are done late in the cycle. Why is that? Because certain security tests, in particular dynamic application security scan, which is like automated pen testing, they require application to be deployed. Application to be deployed, in order for the application to be deployed, we need an environment. And with static environment management, where you have a fixed finite number of those environments in your landscape, the Dust environment, which is typically pretty beefy because you need to be able to support the load of Dust scanners, which are pretty resource intensive, it comes late in a cycle. And so as a consequence of that, developer would first commit the code, it would go through merge request, it would deploy it to the test environment, quality test would go, because the quality tests are easier to do than Dust. Then eventually Dust is done, and then security submits the report, and developer needs to go back and rework something that has been considered done. And in our survey in 2019, we have asked developers that work on GitLab on what is the scope of security vulnerabilities they are able to discover themselves. And 50% of our respondents said that it's not in scope of what they are doing, and the vulnerabilities are typically discovered late in the cycle by security. This is causing at least 2 disadvantages. Number 1 is this lack of psychological safety, that done is done. Number 2 is the risk of delay. When you're getting that technical debt related to security late in the release cycle, the release might slip, or you might be forced into the situation where you accept the risk that you would normally not feel comfortable accepting. And then finally, it's plainly inefficient. Because the developer is waiting on those results, that creates a waste in the process. Now, what you can do when you have CI/CD tightly integrated. By CI, I mean the structure for compiling and deploying the code. CD is representing the control over the infrastructure, actually be able to control your environment. So you can do much better because you can commit the code, then provision the dynamic environment, which you need in order to do all the tests, run all the code and all the actual application deployment tests in one place, let the developer know what the result is, and the developer or developers which are reviewing the code, they know it prior to merging into the master. And because of that, there is at least 3 things you can do. You get that flexibility of making decision with that particular vulnerability. You can say, I'll fix it if it's easy enough in place. You can say, I'll defer that work because it's too complex to be done right now. For example, I need a latest, greatest version of the library, which is already vulnerable, but the fix is not available yet. And it pays from a business perspective to defer the release of particular feature by 2 weeks or so when the patched version comes, and leverage that patched version instead of doing the work yourself. And you can say also, I accept the risk, I release the code right now, but I create a work item, an issue, saying, I consciously create technical debt, and I say, I'll fix that in my next release, in my next sprint. But that freedom of choice is only available if you know about it prior to merge. Once you merge, it's basically way more complex to take those decisions. But in order to do that, you need a critical component. You need that control over the infrastructure. You need to be able to provision that infrastructure dynamically for a feature branch, because the number of feature branches is not static. I mean, developers are working on issues, and every issue has its corresponding feature branch, and it should have its corresponding environment. So now, when you think about it, there is one more hidden advantage, and that's that old code wisdom that there's always a weakest link in the chain, and there's no point securing the door when you have windows open, and hackers can use these. So in order to manage the actual risk, you need to look at several risks which can be introduced into the code, and normalize that risk and think about the actual business risk resulting from it. To give you an example, it's pretty old study done by HelpNet Security, or quoted by HelpNet Security, that roughly 57%, and that was 2017, so 2 years ago already. It's growing rapidly. Of code in enterprise application is not related to their code base. It's related to the open source libraries which are used in those applications. And the nature of open source libraries is you're using something, you're not necessarily getting a warning if there is a vulnerability in it. It's your responsibility to go out and check if the version is really vulnerable or not. And it's a huge scale operation, because when you think 57% of code base, it's actually 57% of the risk surface, at least, because we're only talking about code here, and there is still configuration and infrastructure in place. And that is related to something which is not in the repository. It's just external library, right? So, and then there is Docker images, image dependencies, and then there is other risks as well. And the point here that GitLab is trying to solve is to have every single scanner for SAST, for dependency scanner, for secret detection, for Dust actually, for fast testing, both coverage and API based, executed on every single change, and before that change gets to master. This is the radical shift left concept, where we are talking about not only knowing what is the security of your code prior to releasing it to production, but knowing what is the impact of every change in your code right away. And typical as-is approach is that these scanners are owned by security. These are multiple disparate tools, because you can't have single vendor which will do it all on the satisfying level. And they are integrated somewhere late in the cycle. So you eventually know about it, but eventually it might be too late. Also, a question which very often comes is, hey, but you're providing all those tools within GitLab. What if they're not good enough? The good news is that the primary thing that GitLab is providing is the interface and reporting mechanism. We do provide sample implementations by our scanners, but we're fairly open to just taking external scanner, integrating that with our framework. So when you have external SAST scanner, and that SAST scanner is capable of delivering a textual report, all you need to do is format that output as JSON and pack that scanner as a Docker image, and you can plug it into GitLab, and all the dashboards, all the security reports will be fueled by this data coming from that third-party scanner. So to give you a visual example of how this looks like, a central object from a governance perspective in GitLab is the merge request. Merge request represents all the quality aspects of a change, which is coming to master. And merge request is a collaboration point. It's also a governance point. It has approvals here. It has a discussion thread where the code review group can talk to each other. And it contains, or it should contain, all the relevant information about that particular change. So what is the amount of vulnerabilities in the code? Are there any fixed vulnerabilities? Are there any new vulnerabilities? Are there any licenses which are actually being introduced here? Like, for example, you don't want to accept a front-end code with a GPL license without noticing, because that will automatically open source the code. For backend, it can be even more severe. And all that information should sit in one place so that people can review them, right? And from there, you can easily drill down. You can see what kind of vulnerabilities are there detected, go into the details of particular vulnerability, and decide, jump to the source code, so to understand where this vulnerability sits in the source code, but also decide what do you do with it. Is it something that you keep working on? And in this case, you just rework the code and commit after changes and check if the vulnerability is still there. Do you dismiss that vulnerability? Is it acceptable? Do you create issue to work on that vulnerability later? This is all done by developers, so it's empowering the development team, but it can be tightly controlled by security team on their dashboard. And in some cases, GitLab can even support automatic patching. So for example, if it's just a vulnerable version of the library, you can apply patch with single click and recommit and rescan and know that if the application works, if it passes quality test, then at least that vulnerability is patched from a security perspective. Coming back to the security team view, which still holds the responsibility of making sure that the process works, right? They can see the dashboard with all the vulnerabilities in the code, and they can also monitor the trend of vulnerabilities across a project or group of projects. They can monitor a particular project security status, and they are able to overlook that, jumping into the cases where they are needed. So for example, if we unhide dismissed vulnerabilities, you can see which of them were hidden and try to understand if this is really the justification given is right or wrong. If it's wrong, it still gives the security team the ability to jump in and say, we need to be there. Or in more stricter model, you can also make security team part of the approval board on every change which has any critical or high vulnerability detected. We do have mechanisms for that within our merge request approval rules. So with this, let me jump to some particular examples. One is the quote from Goldman Sachs, VP of Technology, which I'd like to leave you for a second with. The story of Goldman Sachs is that they have made integrated DevOps tool, which was GitLab, available to their developers next to the existing integrated platforms. And 1,500 of those developers adopted that in highly regulated environment within 2 weeks. Why? Because GitLab made their life easier and it made their time more productive. And that is a foundational element for any security initiative. If you have great security tool nobody wants to use, eventually you can force some people to work on that security tool sometimes, but it wouldn't work in a longer run because people need to be comfortable with their work environment. And that example shows that GitLab is also easy to use. But there is other interesting story highlighting that psychological safety coming from Jaguar Land Rover. Chris Hill here is saying, in context of development of their infotainment system in Jaguar, that a developer who is getting information what was wrong with the release after 4-6 weeks release cycle would you would barely know what this is, and switching context is essentially as costly as taking on a new issue. Whereas shrinking that to the 60 minutes from the commit to production that they have right now makes that work much more efficient because you're working on something in a continuous way and you're getting real-time feedback. Is what I'm developing good or not necessarily good enough? With this, this is the material I prepared for today. Feel free to, security is part of the ultimate license package on GitLab. So if you're using GitLab already, feel free to request a trial and try it out for yourself. If not, feel free to experiment with GitLab. Setting up an account on gitlab.com is as easy as providing your username and password. That's all the content I prepared for today. Are there any questions?
So, yeah, thanks, Michał, for your presentation. Yeah, as you mentioned, we still have a few moments for the Q&A left. So I would suggest to start with the questions that we already have, but feel free also, of course, towards the audience to share your questions and your thoughts on the presentation now. But for the moment, I would go with the questions that we already have. The first question, I would say, is quite generic, as we were talking about security. What would you say, how to empower developers to actually create secure code besides providing them with the tools? Is it also a thing of the mindset, or what do you need to do to get the awareness of the people with regard to security?
It's a great question. Well, normally what people are doing on the teams is you pick, and ideally you make sure that people volunteer to be a security champion on the team, and you need a champion on each of the development teams, somebody who is personally interested in security, so does that out of his or her own will, and is willing to guide colleagues on some security related issues. You have somebody local on the team sitting with the others, understanding the security context. And those security champions, they should receive additional materials, additional training from security team. It also should be understood that they need to devote a chunk of their productive time to keep up to date with that area of expertise. That gives the teams a close contact in a hand's reach where they can really discuss their doubts and challenges that they have in their daily work. And that is already a great step forward when you have that structure established.
Thank you very much. The next question is a bit more centered on GitLab itself. How to integrate GitLab with the tools that we are already using, if we have any?
Yeah, so that's something which I only mentioned briefly in a presentation. There are some tools, security tools, which are pre-integrated with GitLab right away. Some others would have community integrations, and in some cases you basically will have to resort to integrating them yourselves. But all of the work which is really needed to integrate that is make sure that either the tool or the script or the agent can be called from our CI/CD, and that's all you need to do is to package this as a Docker container, and then decide format the output as JSON and store that JSON as a deployment artifact in GitLab. When you store the deployment artifact under the right name by certain naming convention, it will be picked up by the engine and leveraged in reporting and made part of that bigger security reporting structure.
Mm-hmm. All right, thank you very much. I think that's all questions I have at the moment. But of course, as for the other sessions, if you have any thoughts or input also for Michał and GitLab, feel free to send us around also later, either via email, or feel free to contact the representatives over our digital event platform. But for the moment, I think we're good. So thanks for your presentation and for answering the questions, Michał. And as he's showing on the final slide, or has showed on the final slide, it is quite easy to get in touch with GitLab and with the tool itself. Thank you very much, Michał.
Thank you.
Bye-bye. Have a nice day ahead.
You too.
Thank you.